So the next topic in the continuation is a recursion. So understand here, recursion is categorized into, recursion means what? Everything I told, okay, the basic points, all the points related to recursion, I told in the first class only. What are all the points, basic points in the recursion? Tell me. Recursion definition is what? Definition of the recursion is what? Function calling itself is called as what? Recursion. And the second point, recursion should definitely have a termination condition. Recursion should definitely have a termination condition. Yes or no? Right. And next I told clearly, okay, if you don't have termination condition, it will lead to what? Stack overflow. That will lead to what? Stack overflow. Next, recursion internally makes use of what? Stack. Okay, all these points I have written in the first class. Recursion internally makes use of a stack. Okay, and next, every time when the recursive call is made, activation record will be created in the stack. Activation record will be created in the stack. And the next point, the creation and deletion of the activation record depends on the actual function calling sequence. Actual function calling sequence. Okay, right. So please understand here what is the meaning of this. And next, recursion is categorized into 4 types. So one is tail recursion. So one is a tail recursion, and next is a non-tail recursion, and the third one is a indirect recursion, and the fourth one is a nested recursion. Nested recursion. Yeah, Govind Mishra not required. You can do in the same manner it is right. Right. So the recursion categorized the 4 types: tail recursion, non-tail, indirect, and nested. Copy this. Right. So first, okay, we'll start with the first one. Note down. Keep the heading tail recursion. So number 1, tail recursion. Note down. Okay. So number 1 is what? Tail recursion. What is the meaning of tail recursion? Note down. In the program, note down the definition. In the program, very last statement. In the program, very last statement is only one recursive call. In the program, very last statement is only one recursive call. In the program, very last statement is a one recursive call. Then it is called as a tail recursion. Okay. So let's see the example. So just copy this tail recursion of integer n. Copy this. So if n equal to 0, so return else. Okay. Printf n, return here of n minus. Okay. Understand this. So this is the tail recursion. In the program, very last statement is one recursive call. Listen here. In the program, very last statement is one recursive call. Then that is called as what? Tail recursion. So नाम से ही पता चल जाएगा, नाम से ही पता चलेगा. So tail recursion. Tail means what? The last statement. Okay. So in the program, the very last statement is one recursive call. That is called as what? Tail recursion. Okay. So now let's see. Okay, is asking what is the output of TR of 3. Just listen here. Tail recursion of 3. So just easy understanding, tail recursion of 3. Now tell me, for easy understanding, okay, you give the numbering. So let's say this is the first statement. Okay, that's the first statement. And the next is what? Okay, this is the second statement. Okay, just for easy understanding. Okay, we are writing the two statements. Now just understand carefully what is the output of TR of 3. Okay, in the tail recursion, listen here. In the program, the very last statement is what? Recursive call, right? Now how you are going to solve this? Okay, you do that with the help of stack. Okay, so take the stack here. So the first TR function will be pushed into stack. So initially, obviously, main function only will push. Everybody knows that. Program execution I told. So the first main function only will push into the stack. So I told you that already. Okay, fine. Listen carefully. So first, okay, first main function will be pushed. After that, TR function will be pushed. So you are pushing the TR function. You are passing n value as what? 3. So it's asking what is the output of TR of 3, tail recursion of 3. Okay. So first, okay, you are passing n value as a 3. You are having two statements. Now tell me what is the second first statement? N equal to 0, return n equal to 0. True or false? False. If it is false, you are saying printf n. So printf n. So you are printing n value. N value is a 3. And you are calling recursively calling TR of n minus 1. So now first statement is done. And second statement, you are recursively calling TR of n minus 1. So when you call TR of n minus 1, recursively calling the TR function by passing n minus 2. Sorry, n minus 1. So n value is what? 3 here. So 3 minus 1 means what? You are passing 2. So again, you will have a first statement, second statement. Now same thing, n equal to 0. True or false? False. You will not do that. Now second some printf n. What is the n value? Okay, 2. And next recursively call TR of n minus 1. So when you say TR of n minus 1, understand here. So TR of n minus 1, you are passing n value as a 1 and again 1, 2 statements. Now what is the first statement? N equal to 0, return n equal to 0. True or false? False. You are not doing that. And next, okay, printf n value is a 1. So that is done. And next, now second statement again recursively calling TR of n minus 1. So n value is 1. So you are passing n value as a 0. And again 1, 2 statements. And now tell me, you are having 1, 2 statements. Now tell me what is the first statement? If n equal to 0. If n equal to 0, you say return n equal to 0. True or false? True. So this is saying return. Okay, in the first statement only you say return and second statement will not execute. So first statement say return kiya, so second statement not executed. Now, so when you return, return means you return to what? Previous activation record. You return to what? Previous activation record. So this will be deleted from the stack. You come back to previous activation record. Now when you come back to previous activation record, do you have any other statement to execute? Do you have any other statement pending to execute? Do you have any other pending statement to execute? No, there is no other pending statement. Now second statement is also completed. So that will be returned to previous activation record. Here when you come back, is there any other statement to execute? No. When you come back to previous activation record, any other statement to execute? No. So now look at here. What is the output printed here? So 3, 2, 1. So that is the output printed. So please understand here what is happening in the tail recursion. What is happening in the tail recursion? You are pushing so many activation records in the stack, and when you come back, okay, so once this is done, when you coming out of this activation record, when you come back to previous activation record, there is no other work to do. There is no any work to do. There is no any statement to execute. Is that clear? Now remember, the main purpose of the recursion is when you come back to previous activation record, there should be some work to execute. Okay, the main purpose, listen here, main purpose of the recursion is when you come back to previous activation record, there should be some work to perform. Okay, there is no work to perform here, right? So it means what? You are pushing so many activation records in the stack, and when you come back, there is no other work, there is no other statement to execute. So remember, this is called as what? Misusing the concept of recursion. Misusing the concept of recursion. Is that clear? So it means like you are pushing so many activation records in the stack, and when you come back, there is no work. So it means there is no, the proper using of the recursion. The main purpose of the recursion Main purpose of the recursion is when you come back to previous activation record, there should be some work to perform. There should be some statements to execute. So here you don't have any statements to execute. यहाँ पे कोई स्टेटमेंट नहीं है एग्जीक्यूट करने के लिए वापस आने के बाद. Exactly. So इसका मतलब है you are pushing so many activation records in the stack, and when you come back there is no other work to do. So that is called as what? Misusing the concept of recursion. Now understand here. So this is given. Now look at here. What is the output you are getting? Okay, you are getting okay 3 2 1. You are getting 3 2 1. Now understand here. I say I will give the n value as a 3 here. I am asking the question here. I will say okay. I will say I will give the n value as a 3 here, because what is the n value passed here? 3. So I will say I will give the n value as a 3, and I want this kind of output pattern. Now can you do that without using recursion? Without using recursion, I will say n equal to 3. I will give n equal to 3. I want output as a 3 2 1. So can you do that without using recursion? Can you do that without using recursion? Yes, obviously it is possible. So it means equivalent recursive program, a non-recursive program. Equivalent non-recursive program is very easy. Why? Because whatever the statements is there, you can simply keep in the for loop. Like you can write, so let's say for example, for I equal to 3. So I greater than or equal to 1. I minus minus. So simply say printf percentile d, okay, I. So now tell me what is the output you get here. So integer I you declare, okay, integer I. What is the output you get here? So first is I equal to 3, I greater than or equal to 1, yes sir. Okay, so printf I. So 3 will be printed, next 2 will be printed, next 1 will be printed. So that's it. So equivalent non-recursive program is what? Very easy. That's it. You can use the simple for loop. You can use a simple for loop, and you can get the equivalent non-recursive program. So when it is very easy, when it's very easy to write equivalent non-recursive program, so the tail recursion is not suggestible to implement. Recursion is having some purpose. Recursion, the facility is given with some purpose. What is the purpose? When you come back to the previous activation record, there should be some activity to perform. There should be some statements to execute. There should be some work. So when there is no work, unless it is something like, okay, you are calling your friend 100 times, and okay, 100 times you call your friend, and when your friend is lifted the phone, you are saying there is no work. You are saying there is no work. ऐसे ही कॉल किया, तो कैसा लगेगा? Right? कैसा लगेगा? बहुत बुरा लगेगा. Yes or no? You call your friends 100 times, and when he's lifted the phone, you are saying, okay, there is no work. So that is very bad. Is that here? Right. So it is something like this. Unnecessarily you are misusing the stack space. Unnecessary you are using the misusing the stack space. Is that clear? Right? So copy this one, copy this one, and copy this one, and this one also you copy. Is that here? I will give the statements. So here, what is the advantage? What is the one advantage of the tail recursion? Advantage of the tail recursion. Listen to me. Advantage of the tail recursion is equivalent non-recursive program. Equivalent non-recursive program is very easy to write, because you can use any while loop or for loop. So equivalent non-recursive program is very easy to write. But what is the problem? Unnecessary wasting the stack space. Okay, copy this. I will give the notes. right? I think copied all of you, right? Note down the statement. Keep it as a note. Keep it as a note. Keep it as note. First point. The advantage of the tail recursion is the advantage of the tail recursion is we can easily write equivalent. We can easily write equivalent non-recursive program. The advantage of the tail recursion is we can easily write equivalent non-recursive program. Right. The second point. The disadvantage is second point. The main disadvantage. The main disadvantage is we are wasting. The main disadvantage is we are wasting lot of stack space. We are wasting lot of stack space. We are wasting lot of stack space. Right. So just understand. Is this clear for everyone? Right. So next. So that is the tail recursion. So next, non-tail recursion. Keep the heading non-tail recursion. In the program, note down. In the program, after the recursive call, in the program, after the recursive call, some statements to execute. Some statements to execute. Some statements to execute. Then it is called as non-tail recursion. In the program, after the recursive call, some statements to execute. Then it is called as what? A non-tail recursion. Okay. Now, so just listen carefully. There are so many questions based on this. So it is very easy, right? Integer, okay, a, you are calling the function a, integer n. So if n less than or equal to 1, okay, return, copy this, else recursively calling a of n minus 2, printf n, recursively calling a of n minus 1, printf So let's see what is the output of A of 4. Copy this. What is the output of A of 4? Now look at here in the program, after the recursive call, there are some statements to execute. Then that is called as a non-tail recursion. So this is the recursive call, there are some statements to execute. This is also recursive call, there are some statements to execute. So in the program, after the recursive call, there are some statements to execute. So that is called as what? Non-tail recursion. Copy karo. Speed up. So it's asking what is the output of A of 4. Okay. So how you are going to do this? Okay, listen here. So integer, okay, n you are passing if n less than or equal to 1, return. Okay. Now remember, so this also you need to solve with the help of stack only, because recursion means stack only, right? I told you. But with the help of stack, okay, it is confusing. But we will use what? A tree method. We will use the tree method. So tree means what? That is also stack only. Is that clear? Internally stack only, but just looks like a tree. Is that clear? So just for our convenience, we draw in the form of tree. So just give the numbering here. Okay, if n less than or equal to 1, simply return. So only give the numbers for this 1, 2, 3, 4. So it means for every function call, you have to execute all these 4 statements. For every function call, you have to execute all these 4 statements. Okay, right. So it's asking A of 4 value, A of 4. Look at here. So n value, this is the n value here. N value given as what? 4. Right. Listen carefully. The next one you are going to solve. Next question you are going to solve. A of 4. Right. So if n less than or equal to 1, simply say return. Otherwise, you are calling all these 4 statements. Now tell me. So 1, 2, 3, 4 statements. Now tell me what is the first statement? What is the first statement? A of n minus 2. Okay. A of n minus 2. Recursively calling A of n minus 2. N value is the 4. So 4 minus 2 is what? 2. So this again having 1, 2, 3, 4 statements. Again first statement. Whenever you call this function, you have to execute these 4 statements. Now what the first statement? Recursively calling A of n minus 2. N value is here 2. N value here is 2. So 2 minus 2 is what? 0. That is A of 0. So A of 0 means what? Termination. Why? Because n less than or equal to 1 so it is return. Listen carefully. The next question you are going to solve. आपको ऐसा नहीं छोड़ सकते, right? Next question आप लोग करोगे, right? So right, A of 0 means termination. Now what is the second statement? Printf n. Printf n. What is the n value in this activation record? 2. And the third statement, A of n minus 1. So A of n minus 1. N value is 2. 2 minus 1 is what? 1. So A of 1 means termination, because n less than or equal to 1 to return. Return means coming out of the activation record, or you say termination. So next, the fourth statement. What is the fourth statement? Okay, printf n minus 2. You are calling n minus 2. So n value is 2 here. So 2 minus 2 is what? 2 minus 2 is what? 0. You are printing 0. Right. So next, now the second statement here. Okay, in the AR4 function, second statement. Second statement is printf n. So what is the n value in this activation record? 4. Now tell me third statement. Third statement is what? A of n minus 1. So A of n minus 1, that is A of 3. Because n value is a 4 here, n minus 1 means 3. So A of 3, it is having 1, 2, 3, 4 statements. What is the first statement? First statement, A of n minus 2. Recursively calling A of n minus 2. So that is A of 1. Because n value is 3. So 3 minus 2. 3 minus 2 is 1. A of 1 means termination. Now second statement, printf n. What is the n value here? 3. So next third statement, A of n minus 1. A of n minus 1. N minus 1 means what? N value is 3. So n minus 1 means A of 2. N minus 1 means A of 2. Right? Next, A of 2 again you solve. 1, 2, 3, 4. Now what the first statement? A of n minus 2. So that is termination. That is A of 0. Okay. Now second statement, printf n. So n value is 2. Now the third statement, third A of n minus 1. So that is A of 1. A of 1 means termination. Now the fourth statement, printf n minus 2. N value 2. 2 minus 2 is 0. And next, what is the fourth statement here? Fourth statement, printf n minus 2. So n value is 3. N value is 3. 3 minus 2. 3 minus 2 is 1. Okay. And next here also fourth statement pending. So printf n minus 2. N value is a 4 in this activation record. N value is a 4 in this activation record. So n value 4 minus 2 means what? That is 2. Right? Okay. So what is the output printed? How the output printed? Listen here first. How the output printed? Now tell me, what is the first printf statement? What is the first output comes? This is the output. Okay. You have to go in this direction. You have to go in this direction. Is that clear? Right? First is 2 printed and next is 0. Next is a 4. देखो here file. Next is 3 and next is a 2. Next 0. Next 1. Next is a 2. So that is the order of the output. So tell me output printed here. So 204, 204. Okay, 3, 2, 0, 1, 2. So this is the output you are going to get. So 204, 3, 2, 0, 1, 2. Copy this. Copy this one and copy this one. Speed up. Copy करने के बाद मैसेज करो. Copied all of you. Your comments are not coming to me. I don't know, some problem is there. Yeah, some your message is not coming to me. Okay. I think all of you copied. Yeah, in my PC. Yeah. Okay, now it is coming. Okay, okay. Right. Now take the next example. आप लोग करोगे. Right. So take the next question. You guys has to do this. Okay. If n less than or equal to 1. If n less than or equal to 1, return. Okay. So else printf n minus 3 a of n minus 1 printf n minus a of n 1 n of n. So these are the statements you are having. Printf n minus 3, n minus 2, n minus 1. So a of n minus 3, n minus 3. This is a of n minus 3. Okay. So now take this question and tell me what is the output of same a of 4. What is the output of a of 4? जैसा मैं सॉल्व किया ऐसे ही सॉल्व करो. Just copy that carefully. Copy the program. Same thing. If n less than or equal to 1, return. So okay, printf n minus 3 a of n minus 2 recursively calling and tell me what is the output of a of 4. जल्दी करो. Yeah, Dev कह रहा it is also you can use stack also, but stack will be more complicated. It is the stack only. Okay, right? You can use stack. Stack use करे तो थोड़ा complicate हो जाएगा. बस इतना ही. Yeah, Ravish, anything you can use a tree method or okay, you say tree method use karo, ya to you can use what a stack method. But what is there? Actually, it is a stack only. Just for our convenience, we are writing in the form of tree. अपन ट्री जैसा लिख रहा है अपने को अच्छा समझ में आने के लिए, अपने को इजी होने के लिए, मगर सच में तो स्टैक ही है. Actually, it is a stack only. Right. So if you have copied, so take up the next question and find out what is the output of EF4 and give the comment. So what is the answer? Yeah, I think most of you got the same answer, right? 1 0 1 0 minus 1 0 2 1. Okay, answer I am writing here. 1 0 minus 1, right? That is answer. 1 0 minus 1. Next, what is this? Different people are getting different answer. 1 0 minus 1. Okay, 0 2 double 1. 0 2 1 1, right? 0 2 double 1, right? 3 2 minus 1 0. 3 2 minus 1 0. 3 2 minus 1 0. Next last one is what? 2 1 4 3, right? 2 1. This is the output. Don't do the calculation simple mistakes. Somebody, tomorrow timings I already told you, 9 to 6. Harshita Srivastav, tomorrow timings I told already, 9 to 6. Right. So this is the answer. So 1 0 minus 1 0 2 1 1 3 2 minus 1 0 2 1 4 3. So check it out. Is that correct answer? What is this? Last history you're saying 3 2 2. So check it out. Abhijit Manoj, you gave wrong answer. What is that answer, Abhijit Manoj? 2 times 2 after 3. Oh, okay, okay. Sorry. I think so then, yeah. So printing mistake. So here this is the 3 2 2. Okay, last history you are right. So 3 2 2. Right. So whatever the answer you are getting, so that's it. After Bansari, you are giving wrong answer. I don't know somebody giving wrong answer still. You are getting 5. How you got 5? Then n value is a 4. When n value is a 4, how it is possible to print 5? After Bansari, check it out. Yeah. Aishwarya 3 2 2 होना चाहिए. Yeah, it's okay, it's okay. Whatever is there, it is very simple. Okay, right? Simple. Right. So understand here. So this is the answer. Now, if you observe this non-tail recursion, right? After the recursive call, there is some work to do. Okay. After the recursive call, there are some statements to execute. Yes. So there are some statements to execute. So that is called as what? Non-tail recursion. Okay. After the recursive call, some statements to execute. That is called as a non-tail recursion. So if you observe this non-tail recursion, just observe the output there. If you observe the output, okay, one thing you can understand very clearly, the n value given as a 4, n value given as a 4, and you are getting this is the output. When n value given as a 4 and this is the output you are getting, right? Yes or no? Right? Right. So n value given, okay, understand here. N value given as a 4 and you are printing this output, you are getting this output. Okay, so it means what is the important line you can understand. Okay, do you find any relation in this? Do you find any relation in the outputs? No, is that clear? So it means writing the equivalent non-recursive program. Writing the equivalent non-recursive program is very difficult to write. Very difficult. So writing the equivalent non-recursive program is very difficult. Is that clear for everyone? Right? So understand here. So if I say n equal to 4, okay, you are getting this as output. Writing equivalent non-recursive program, okay, is difficult to write. Is that clear? Right? And remember, it is not misusing the stack. So if you want, okay, this kind of output, definitely recursion is useful. There are some statements to execute. Okay, it means you are not misusing the recursion here. So this is fine, recursion is fine, but writing the equivalent non-recursive program is very difficult. It is not possible. You cannot say it is not possible. You cannot say it is not possible. Everything is possible, right? So it's a very simple, okay. Somehow you can find out. Somehow you can find out. but it's very, very difficult, complicated. Okay, so to write equivalent non-recursive program with a simple for loop, with a simple while loop, it is not possible to write. With a simple for loop, with a simple while loop, it is not possible to write. Is that clear? So just check it out. So somebody saying output is something is wrong. Check it out. Whatever output you are getting, so solve that. Okay, I think this is the right. So note down the statements. Note down the statements. So check it out. Why you are worried? Simple question. That is the right answer. Almost 90% answer is matching. If you are getting wrong answer, if you are getting wrong answer, solve it again. For the small question also I have to solve again. Small question को फिर से भी मैं solve करूँ क्या? Right. Note down the statement. Note down. Keep it as a note. The main disadvantage of non-tail recursion is the main disadvantage of the non-tail recursion. Non-tail recursion is writing. Main disadvantage of the non-tail recursion is writing the equivalent. Writing the equivalent non-recursive program. Writing the equivalent non-recursive program. Writing the equivalent non-recursive program is possible but very difficult. Writing the non-recursive equivalent non-recursive program is possible but very complicated or difficult, whatever it is complicated or okay difficult, right? So is that clear? So that is okay non-tail recursion. Okay, right. So next in the continuation we are having what indirect recursion and nested recursion. Is that clear? So indirect recursion and nested recursion we'll study in the tomorrow's class, right? So indirect recursion, nested recursion is there, and that will take only half an hour, 1 hour. And one more small topic is there, dynamic memory allocation. So that will take around 40 minutes. So once these two are completed, we will enter into data structures. Is that clear? So I'll stop the class for today, continue tomorrow. Is that clear? So tomorrow timings is 9 AM to 6 PM. Type చేసేనా పెట్టేసాను ఒకసారి message. So tomorrow timings will be 9 AM to 6 PM, right? So I'll stop the class for today. So see you tomorrow. Is that clear? So tomorrow morning we are having class. So that is the reason I am leaving early. थोड़ा जल्दी छोड़ दे रहा हूँ आपको, right? So notes को revise कर लो. So tomorrow class we'll study okay remaining topics in the recursion, indirect recursion and nested recursion, and then we'll study dynamic memory allocation, and then I will enter into data structures and I will start the linked list. So linked list मैं start कर दूंगा कल. Is that clear? Right. So fine. Okay, right. And the next data structures also requires around 6-7 classes. Data structures, I mean it will not take much time, but let's see okay what is going to happen, how much time it will take. Okay, so see you tomorrow morning 9 o'clock, right? Bye.